Hi everyone, welcome to Byte and Beyond with Uday. In this video, we are going to learn about transactional annotation. So today's agenda will be we will see the problem without transactional annotation, and then we will fix that problem using this annotation. Okay, so let's begin. So here is the problem. So here is the user like us. We are trying to store or persist employee and the ID card object or entity. Now, let's say once our request reaches to service layer, employee gets saved, but before we save ID card, there is an exception. So, if we do not use transaction, then employee will remain saved in the database, but ID card is not saved. So there is inconsistent data in our system or in our database. So our problem will be like employee exists, but ID card is missing. But in our case, both should be available because as a user, we are sending employee and the ID card, and our expectation is both should get saved in the system, employee and the ID card. But it is not happening because before we save ID card, there is an exception occurrence. So let's jump to the practical and let's see the problem for real. So I have prepared one API to demonstrate this problem. So here is the service layer method where we are going to simulate this problem. All right. So this method name is create employee and ID card for transactional demo. Okay. So this is pretty simple. I am preparing employee object. Then I am storing or I am saving employee object in the database. All right. And as per the true and false, this will be our request param. We are getting this argument or parameter from the controller. So if we pass true, it will throw an exception. This one. This is intentional, right? Because we want to simulate a problem that what will happen without transactional annotation or transactional. Okay. Then let's say if we are passing true, then it will throw an exception. So without transaction, we will only have employee. But let's say I'm passing false. So this the flow will not go inside this if condition, and we will prepare this ID card object. Okay, and we are storing this ID card in the database. So pretty simple. Prepare employee object, save in the database. If should fail is true, throw an exception to simulate our problem. If it is false, skip this part, throw exception, skip it, prepare ID card object, and save ID card in the database. Pretty simple, right? And here is the controller. This is our endpoint at the transactional demo. As I mentioned, I can pass either true or false. True will throw an exception. Okay, and false will skip it. So if everything goes fine, if there is no exception, we will get this response. If there is an exception, we will get this response. Pretty straightforward, nothing, there is no rocket science over here. Pretty simple API. All right, so let's go to the Postman and let me, before we go to the Postman, let me start our application. My MySQL database is already up and running. Let me refresh this. Okay, there is already one uh, user is available. Let me delete that user first of all. So our application is up and running. Let me delete the existing user. Okay. Okay. All right. It is deleted. Let me refresh my database. Okay. There is no ID card. There is no employee. All right. Perfect. So we are ready to see this problem. All right. Which we are seeing in this slide. So here is our API post, and I'm not sending any body because in our API itself, we are preparing a dummy object. All right, perfect. So, but yeah, you can see I am passing should fail as false, but let me keep it as true. Okay, so let me send. Let me hit the this send button. Let's see what happens. So you can see I am getting this you know error response basically with 500 internal server error. So what it says, transaction failed and was rolled back. Error simulated ID card save failure after employee save. Okay, so this is just simple error message. So we are not using other transactional. So our transaction should not get rolled back. So let me show you the situation which we are seeing in the slide. So employee will remain persisted, but ID card is not persisted yet. And we will ending up in the situation where employee exists, but ID card is missing. So let's verify using our GET API first of all. Okay. Mhm. This is pretty simple verification. So if I hit this send button, it will it will give me all the available employees in our system and as well as the ID card. So as you can see, we have only one employee, Harry Potter, and there is no ID card. Right? So let me jump to the our API. You can see this is the object which we can see over here. All right, it is saved successfully, and because we are should fail sending as true. So this if condition will become true, and we are intentionally throwing an exception. Now, because it throws an exception, we are ending up in the situation where employees remain persisted, but ID card flow is yet to be executed. Right? So in our system, only employee is available and ID card is not, as per this given slide. Employee is there, but ID card is not. We can verify in the database as well. So there is no ID card, you can see, right? But if you go to the employee table, there is an employee available. But this is not the right behavior because either both entities should get saved, all right? Either employee and ID card both get saved, or none of these get saved. That should be the behavior. This is wrong behavior. All right. So to achieve this, to solve this problem, I would say rather than achieve this, to solve this problem, we need to use at the rate transactional annotation. This one. So let's use this at the rate transactional annotation. So for that, I just need to. That is pretty straightforward. Let me use this at the rate transactional annotation and make sure it is from Spring Framework transaction annotation. Okay. So I have used it, and let me restart my application. Now you can guess what will happen. So if after even after employee is saved, if there is any exception, there will be rollback. Rollback meaning undo the changes whatever is done so far. So whenever there is an exception, employee is saved. So we will remove the employee from our system. All right. So that is called rollback. If employee is saved, these changes are persisted, and there is an exception, we are going to undo those changes or remove those changes from our database. So that's what we are going to achieve with this annotation at the transactional annotation. So our interaction with database run within the transaction, and it will be monitored by the JPA. If there is any exception, JPA will identify, yes, there is an exception, let me remove this employee from our system. So there will be consistency. So there will be consistent data in our system. All right. So let's keep this theory, and let's jump to the example. So before I show you the example, let me delete this employee from the database. So for that we have our delete API that will help us to delete an employee and the ID card. All right, there is. So delete is happened 204 no content, meaning success. And if I refresh my database, you can see there is no employee and there is no ID card. All right, perfect. And now as we are using other transactional annotation, so let me hit this post API with true, and let's see what happens. We are getting exception, that's fine. But our objective was to, there should be no, if employees get persisted, it should get rolled back. All right. So if we are currently saving employee and there is an exception. All right. So our expectation is, if there is an exception, there should rollback happen. So employee should get removed from our system. Let's see. Let's hit this get API and see what we will get. You can see there is no data available in our system. Zero. That you can see. We can verify the same by going in the database as well. If I refresh my tables, there is no employee, there is no ID card. So, this is the magic of using other transactional annotation. All right. So you can see initially there was insert statement, but it was not committed yet. There is insert statement, but it is not committed. All right. And when there is an exception occurrence, so let me explain what exactly happens. We are trying to save employee. All right, it is get saved, but transaction is not committed. Uh, in order to save data in our database, we need to commit. So JPA hasn't committed yet, and this is commit, there is an exception. So whenever there is an exception, okay, whenever there is an exception, it has rolled back the changes. The changes meaning it has rolled back the employee entity. It has removed the employee entity. So there is no employee entity in our system. No, it doesn't matter how many times I hit this API. All right. It doesn't matter how many times I hit this API. 10 times, 15 times, it doesn't matter. And if I use this get all APIs, there won't be any employee because whenever there is an exception and we are using the transactional annotation, if exception occurs, it is going to remove all the previous changes. All right. Perfect. I hope this is clear. But now let's say what if there is no exception? So in that case, let me go to the database and show you this. Show you my table that there is no employee and there is no ID card. But yeah, let me show you an example that what happens if there is no exception. If there is no exception, then both entity going to be saved successfully fine. So let me use the false. So if I set the false, this if condition going to be skipped, and if this if condition going to be skipped, there won't be any exception. All right, let me hit the send API. You can see we are getting the success response. Success, employee and ID card saved in one transaction. And now if I use this get all employees, I will get both employee and the ID card. All right. And I can go to the database. If I refresh my tables, there is ID card details and there is employee details. So, this is the magic of transaction. But you are might thinking, what happens if both objects are saved and then happen the transaction? Then what will happen? So let's simulate that example as well. But before we simulate, let me delete our current employee. So now if I verify that there is no data available in our database, we can verify that in the DB as well. Employee, there is no ID card, there is no employee. Perfect. That's what we needed, right? So as per this slide, that was the one of the example. What happens that we have just seen that if employee gets saved and then there is an exception, what will happen? So in that case, employee will get rolled back. But what will happen when employee gets saved, ID card gets saved, and then exception occurrence? Then both entity, employee and ID card, will get rolled back. All right, let me show you this example. So as you know, there is no employee and ID card in our system. Perfect. And as you have noticed, now I have you know moved this intentional exception occurrence at the end of the method. So I am persisting employee, I am persisting ID card, then I am throwing an exception intentionally. So after this change, let me restart my application. All right, our application is up and running. Perfect. So you can guess as per this slide. So with other transactional annotation, both entities should get rollback. All right. So let me hit the send button. Oh, we are getting, success response. That's strange. Looks like our changes are not getting picked. Local changes are not getting picked appropriately. So let me do one thing. Let me delete this current data from our system. Okay. And as it is not picking my latest change, let me do one thing. Let me stop our application. Let me go to the terminal. Let me repackage my application once again. So repackage meaning I am going to do mvn, just a moment, mvnw, sorry, yeah, mvnw clean package. So this will help me to clean my previous code changes and it will help me to create new packages. All right. It is running test cases, default test case. That's fine. And our package is ready. Now let me restart our application or start our application and let's see what happens. All right, perfect. Our application here is up and running. Let me show you the database. There is no existing data available in our system. All right. Okay, perfect. Now, as we are, okay. I think, yeah, one mistake from my end, that I was sending false from here. That was one of the mistake I did. So let me send the true. So it means I want to throw an exception. So let me hit the send button. So yeah, you can verify this using this send button as well. There is no data available in our system using this get API. We have verified. Now let me hit hit this send button. You can see our transaction get failed, and you can assume what should have happened. Both employee and ID card is not persisted, right? You can see over here. As per the slide, we have saved our employee, we have saved our ID card, and then there is an exception occurrence. So both operation get rolled back. So there is no data saved in the database. So what basically transactional help us to achieve? It basically commit everything. There should be everything successful or nothing should successful. All right, meaning both employees should get saved successfully or nothing should get saved. So with the transaction, either both entity will get persisted in our system or nothing will get persisted in our system. So that will help us to achieve consistency. Our data will remain consistent, and user will think like, yes, I have tried to save my employee and ID card object in the system, but there was an exception occurrence, so nothing is saved. Now I need to try once again. But without transaction, employee and either employee will get saved or ID card will get saved. So we don't want to ending up in those kind of situation. All right. So that's where the at the rate transactional annotation help us. There are many more benefits of at the rate transactional annotation, but in this video I have covered one of the main feature or one of the main benefit of this annotation. All right. Perfect. And as a bonus point, I would like to explain that we can, declare this at the transactional annotation at the method level, as well as if I want to declare it at the, at the class level, I can do that. Additionally, if my API is, read only, in that case, I can mention that, you know, that this is read only true. All right, meaning I am not performing any write operation over here. I am This API is meant for reading the data only, not manipulating any data. Just read the data, that's it. So I can use it at the method level as well, and we can use the combination as well, meaning I have used other transactional annotation over here. By default, it is meant for write and read both. Okay, so I can remove it from here and I can keep it at the class level. So whenever I apply this annotation at the class level, it is going to this other transactional annotation is going to apply to the all the public method of my service class, whether it is save, whether it is create employee, this our current API, whether it is update. But let's say somewhere I want to change the behavior, I want to make my transaction read only. At that time, I can explicitly declare at the method level as well. That is also fine. So we can use combination of usage. I can declare at the class level, and along with the class level, I can declare at the method level. So this method level has the high priority. So instead of class level annotation, this annotation will get applied, where I want to make sure that this transaction should be read only. It should not write anything in my system. All right. So yeah, this is the simple example from my end. There is another example. All right, a simple example, or you can connect with the real world. So we already know now what is transaction. We are trying to save employee and save ID card. If everything is fine, there is no exception. We are both data will get saved in the database. If there is an exception, there won't be any data in the system. All right. So transaction ensure consistency by committing or rolling back all operations. Meaning, if successful, save everything. If there is an exception, remove everything. Do not save anything. All right. So that is transaction. Now, if I give you the simple real world example, let's say we have account A and B. Now, account A has currently 1000 rupees and account B has, let's say, 500 rupees. And we are transferring rupees 100 from account A to B. Now, what will happen? If everything goes fine, then account A balance is 900 and this is 600. That is fine. But without transaction, what will happen? Without transaction, what will happen? That I am transferring 100 rupees from account A to B, but there is an exception. So I will ending up in the situation where money is deducted from account A. So I can see 900 rupees. But the money is not reached yet in the account B. So account B balance is still 500. So this is a huge trouble. This is a huge problem, I would say, because nobody want to ending up in this situation where I have sent the money, but money get deducted from my account, but it is not reached to the recipient account. So our banking application, whether it is any bank in the world, those banks also use this at the rate transactional annotation in their Spring Boot application, or they are using this transaction in their application. But let's say we are using at the rate transactional annotation, or bank basically use this transaction. All right. So in that case, I have sent the 100 rupees, but let's say for some reason operation failed. So in that case, this 100 rupees again going to credited in the account A. So there is a rollback happen. All right. So there will be no inconsistency. Account A balance remain as 1000 and account B remains 5 uh, 500 rupees. So we don't want to ending up in this situation like this. All right. So to avoid such situation, we should always run DP operation within the transaction. So to achieve the transaction, we can use this at the rate transactional annotation at the class level or at the method level as per our business requirement. So that is it for this video. I hope you have learned something meaningful today. If you like my video, then please share, subscribe, like, comment. See you in the next video. Bye.